So today, last class, we have discussed about the thermocouple. We are discussing our subject name is sensor and transducers. We have completed three modules and we have started module four. In module four, we have discussed about the thermocouples. In module four, today we will discuss about the RTD. What is the RTD? RTD is resistance temperature detectors that is used for detecting the temperatures. RTD works by using the basic principle is temperature of the metal increases, so the resistance of that metals is increased. How does its resistance can increase using if the metal temperature increases? An electric current pass through the sensor, so resistance element used to measure the resistance of current being passed through it means this is the art. Suppose that this is the RTD. We will discuss. Suppose that this is the RTD is the here. If we increase the temperature, we increase the temperature across this. We increase the temperature across this RTD. So then its resistance will increased based on the this. Sometimes just this resistance generally look like this. Some metal look like this state, some metal look like this. So based on the metal, but it's generally linearly increase. Some metals are more linear and some metals are less linear within the limit range of temperature. In this here, in x-axis is the temperature, the y-axis is the resistance. How are increasing? So this then classification of RTD. RTD are broadly classified according to different sensing elements used, like platinum, nickel, copper are most commonly used sensing element. Platinum type RTD is known as its best interchangeability than copper and nickel. It has a highest stability time. That's why in more linear, three highest stability, best interchangeability, and most linear. That's why we use generally mostly platinum RTD. Working principle of RTD. RTD one the basic correlation between the temperature between the metal and temperatures. Between the it's generally working depend between the metals and temperature. As temperatures of the metal increases, so resistance increases. As metal temperature is the temperature of the metal increases. This is the metal M. If temperature of this metal increases, the metal resistance to flow the electricity increase. So this metal, if temperature of this metal increases, then the resistance of resistance increases. Resistance increases is nothing but to increase the to create the resistance to flow the of electricity increases. Similarly, temperature of RTD element increases and electrical resistance measured ohms increases. RTD elements are commonly specified according to their resistance ohm 0 degree Celsius. So, see, simple principle based on this: metal temperature increases, then resistance increases. If metal temperature decreases, then resistance. Generally, the behavior are linear. Most commonly used are platinum. In most commonly used is a platinum metal for RTD element. There are so many regions. Why we have first region chemical inertness. Generally, the platinum doesn't react very fast. So so this is because of its chemical with the chemicals. That's a chemical alertness. दूसरा near, this is the, it's a graph between the temperature versus resistance for platinum is generally, this is the linear. The second, linearly temperature versus resistance relationship. Next is a temperature coefficient of large to give the measurable output. Means we got temperature coefficient of resistance to high, because this equation RTD equation, RTT equal to R0 R0 into 1 plus alpha dt t, like this. So means this coefficient sufficient large, so that this coefficient sufficient large, so that we can measurable, it give provide the measurable resistance output with change in temperature. And fourth point, stability is the temperature resistance doesn't drastically change it with time. Means stability, if give the stable output for long time, it's provided if it, its temperature versus resistance gives the linear graph for more time, it does not change it sudden or drastically. RTD element typically three configurations. We RTD are typically in one three configurations. First, platinum or metal Sellerige film, that is screen onto substance known as thin film RTD. So, one name is a thin film RTD element. In how it would look like? First, platinum or metal glass Sellerige film deposit or screen into a small flatness ceramic substance. Suppose that this is the small flatness ceramic substance, RTD material are putted here. Is like this, like this. This is the thin film element is this. Second is a platinum wire wounded on glass ceramic Robin seal coating model is known as. Second, wire wounded is RTD is there. First, within this flat RTD like this. Second, other configuration like this wire bonding within this wire bonding. Third, partially supported board element which coil is not inserted on it. So the conductor most commonly used in industry is platinum, but copper and silver conductor also used. PT100 is most common used in industry is PT100. The most common used in industry is referred as PT100. The resistance, why the name is PT100? Because resistance of the 100 ohms at 0 degrees Celsius. Its resistance PT100 means this PT100. This is the PT100 means PT100 means resistance R0 is 100 ohm at 0 degree Celsius. That's why it's done. The constructions look the RTD assembles. So this is the construction here. You can see this is the sheath, outer spaces. This completely outer spaces between this and this is a sheath. Within that small, this is here RTD जो put it here. RTD two was like this. RTD put here. Then this is given to here to here. This is the lead connection from here. Connection lead. These are connected to collect. These are connecting to connecting lead. This is here question. Connecting leads. And within this we have put it again one insulator. Within it is a put again within the insulator like this. We can use. So this is general diagram. Lead wire is there. Process connection we are providing for by this is the nut bolt type connection here. It can open and close by here. This is the it go within the process. We suppose that we want to measure temperature this tank, so it can go within the process within it. This is the connection, three wire. This is the 3 point. It look like three wire connection. The generally RTD are two wire connection, three wire connection, four wire connection. So generally two, three, and four wire connection generally used. And this is the outside diameter, and this is the platinum. This within this look like this. This is the platinum. This is the RTD sensing element. This is the sensing element. So RTB different connection. This here different connection, like this is a two wire connection. Suppose this is the power supply. This is the Wheatstone bridge. One arms is the RTD is connected. This is the RTD is connected between the one's arms, and output is taken here. This a two wire connection look like this. So when and why we use the two wire connections? First, this is a simple resistance thermometer configuration. Simple resistance thermometer use the two wire connection. First, it is only used when high accuracy is not required. If not required high accuracy, not required high accuracy, high accuracy. If high accuracy is required, we cannot use it. Is resistance of following connector wire added? Why it not good? Because it does not eliminate the lead resistance, which we are seeing the lead element here before. Just we have seen this is the lead element just before. This is the lead. So lead element. This is the lead element. Look like this. This lead element give their effect on the reading. That's why because of this it cannot be used for the. Hmm. Because lead wire resistance added for reading, that's why this sensor does not give the highest accuracy, leading to the error measurement. This configuration uses 100 meter of cables, so apply equivalence to fixed bridge. Second is a next is a three wire look like this. This is the power supply PS. This is the power. This is a Wheatstone bridge. We are taking output between here. This is the RTD is put it here. RTD is put it here. One wire connect. This is the lead resistance for balancing to eliminate the error, because error effect can be minimized using this. So one is connected between, and one is connected from the power supply. Here power supply negative terminal connected like this. So this is configuration, three wire configuration. This is the three wire configuration. This is the three wire configuration. Why we use the three wire configuration? To minimize the effect of lead resistance, because such two wire lead effect, because of lead effect lead resistance is added, so it it will not give the more output more accurately. So we use the three wire configuration. R1 and R2 R3 are in middle, and Wheatstone based on we have shown in here. So the output effective. This is a three wire we have. So PT and this, and sometimes four wire are can be also used, but it provides more accuracy more than compared to three wire. But that's costly, so we will not just practically that will not applicable more, but it gives the more accuracy. Characteristics of RTD. How the RTD look like? Important characteristics of RTD, like temperature coefficient of resistance TCR, nominal resistance at 0 degree Celsius. So this is the characteristics we will discuss about the characteristics of RTD. Suppose that this is the graph. This is the here the temperature. Here temperature. Here RT particular T degree centigrade resistance of RT divided by R0 resistance of T0. So we can draw the graph between platinum. Generally we can use because this is the more linear. Because this is the more linear. That's why we use the PT. Nickel is a more sensitive, but it is the more linear. Look like this. Copper, copper and sensitivity. When we talk about the sensitivity, because nickel and copper has more sensitivity, but platinum is more linear and accurate. That's why because of linearity, stability, inertness of this we can how this if we talk sensitivity, what is the sensitivity? Change in out, change in input by change in yes, sensitivity and the change in output by change in input. So that's why, so this nickel and pt have more sensitive than compared to platinum, but these elements are not more stable for long time, and or platinum resistance are uh, high chemical inertness. That's why we are generally use PT100. Application of RTD. RTD sensor used to automotive measure the इंजन टेम्परेचर. ऑटोमोटिव्स में जनरली आरटीडी का यूज करते हैं. ऑटोमेटिव मेजर द इंजन टेम्परेचर्स. ऑयल और सेंसर इनटेक टेम्परेचर एयर सेंसर. Communication communication and instrumentation for sensing the over temperature of amplifier signals. Generally we discuss the equation RTD. RT temperature at T degree. This how we let R0 जो resistance is 0 degree Celsius into 1 plus alpha delta T. This is the approximated RTD equation generally which can be used to measure the temperature. We can like this temperature at RTD. What is the first advantage RTD? Because RTD has stability. It's provide stable output. दूसरा precision but and repeatability. So RTD has first stability, second precision, second repeatability. Disadvantage, response time is very high, price is very high. That's why we have to maintain it. Response time is very high. RTD we can, this RTD graph we can use anywhere. It provides a stable output. That's why this is a precise, very precise and repeatability. Why repeatability? Because of we have used the, because we have discussed just before, platinum they has provided more stable output for long time. So this, in this sector we have completed the RTD. RTD was here you have to write the memorize the equation RTD. We have not written this RTD equation. RT equal to R0 1 plus alpha delta T. Alpha is the temperature coefficient. This is the alpha temperature coefficient. For platinum just like 0.3 0.0384. This is the temperature coefficient value. Sometimes they will give the PT and ask the temperature, particular temperatures. Suppose for If suppose sometimes they will give R0, the resistance at 0 degree Celsius is 100 ohm, and find the resistance RT at 100 degree Celsius. 100 degree. So that time we can use this equation, R बराबर RT R0 into 1 plus alpha delta T. We know the alpha value 0.384, and R0 is given 100, and delta T is nothing but we put delta T is nothing but what is the we want to find at 100 degrees Celsius. 100 minus what is the R0 resistance, it rest 100 ohm. What is the R0 means 0 degree temperature, so minus 0 equal to 100. Suppose R0 value is 100, 100, and this 1 plus alpha value 0.345 into 100, and we can solve this. So we can find in this way we will do the problem. So this in this class we have discussed about RTD. Next class we will discuss about the thermistor.